Using artificial intelligence, we are trying to create machines as intelligent as human beings. In this video, we will discuss about deep learning in robotics from object detection to real-time decision making. So we will try to understand how we can build smart robots by optimizing robotic performance using deep learning and meta-heuristic optimization algorithms. So step by step, we will try to understand this process using different examples for better understanding. To build smart robots, we are using here deep learning and optimization techniques. So first question is why we want to optimize robots' performance. Here optimization is about fine-tuning the robot's actions, decisions, and paths to make it work faster, more efficiently, and with fewer errors. This helps the robot to be more effective in its task like moving, picking up objects, or making decisions. In simple words, optimizing a robot's performance is like teaching it to be smarter and more efficient in its work. So it can get the job done better and faster. So here, why we are optimizing the robot's performance to make it work better, faster, and more effectively. Now let's try to understand this with an example. Imagine you have a delivery robot that needs to move around in a warehouse, picking up items and delivering them into the right spots. Now we'll try to understand here why optimization is important. So here we have two cases. First, how robot will perform without optimization. Second, robot's performance with optimization. So without optimization, the robot might take longer routes that result in time wastage, energy wastage, and it could carry items inefficiently, like picking up one item at a time instead of grouping them. And robot might make more mistakes like bumping into obstacles or misplacing items. Second, we have robot performance with optimization. First, we have faster routes. By optimizing the robot's path, robot can find the shortest and the quickest way to move around the warehouse that result in time saving. Second, after optimization, we have better efficiency. Now the robot can be taught to pick up multiple items in one trip that reduce the number of trips needed. Third, fewer mistakes. Because optimization decision making help the robot avoid obstacles better and place items more accurately. So why we are optimizing robot performance? First, it saves time because optimization make the robot faster, which means now the robot can do more work in less time. Second, we can save energy. Now robot is using less power because here now it can perform more work in less time. So now robot will use less power, which is important if the robot is running on batteries. Third, we can increase accuracy. Now the robot makes fewer mistakes, which means less time fixing errors and more reliable performance. Second term we are using here deep learning. Here deep learning acts as the brain of the robot, helping it to see, understand and interact with the world around it. So deep learning allows the robot to recognize objects, understand its environment, make quick decisions and learn from its experiences. So done. So using deep learning, we are making the robots more intelligent and capable of performing complex tasks like we human can do. So why deep learning is important? To make the robots smarter and more capable. For example, first case we have object recognition. So here we can use deep learning that can help the robot to see and recognize different objects using cameras or sensors. For example, the robot can identify a cup, a pen, or a bottle just like we human recognize objects with our eyes. So we have eyes. In case of robot, we are using the camera's sensor so that it can see then deep learning so that it can identify. So this ability is important because the robot need to know what it's dealing with to interact correctly, like knowing to grip a cup gently or to avoid knocking over a bottle. Second, understanding the environment. So deep learning allows the robot to understand its surrounding. Using deep learning, robot can identify obstacles, pathways, or even people, helping it to navigate in a room or a busy warehouse. So, by understanding the environment, now the robot can move around without bumping into things or getting stuck. Third, we have real time decision making. Using deep learning, robots can do real time decision making because deep learning enables the robot to make quick decisions based on information it receives, like we human do. For example, if an obstacle suddenly appears, the robot can decide instantly whether to stop, slow down, or change direction. So this ability to make decision in real time is important for tasks like avoiding collision, picking up moving objects, or following a person. Fourth, we have learning from experiences. Like we human learn from our mistakes. Here, we can train the robots to learn from its mistakes, from its past experiences also. So deep learning allows the robots to improve over time by learning from its experiences. If it makes a mistake like dropping an object, it can learn from that mistake and do better next time. So this makes the robot more reliable and efficient as it continuously improves its performance. Now next we will understand how deep learning can be applied to robotics. First, we discuss the role of optimization, then, what is deep learning, how it is helpful for the robots. Now, how we can apply deep learning to the robots. First, we have perception. So, in robotics, perception means we are making the robot aware with its surrounding. So, it means how a robot uses its sensors like cameras, microphones, or touch sensor to understand its surrounding. So we are making the robot aware with its surrounding. It's like the robot ability to see, hear, or feel the world around it that is helping the robot to make decisions or perform tasks. For example, robots can use perception to detect an obstacle in its path and then move around it. So deep learning help in creating and updating maps of unknown environments while keeping track of the robot's location. Second, we have control. Now suppose we have to move the robot in complex and unstructured environment. So here we need end-to-end learning. So instead of manually designing control policies, deep learning can be used to learn control actions directly from sensor input. Third, we have planning and decision making. So robots can learn optimal action in dynamic environments, making them suitable for tasks like navigation, manipulation, and games. So we can use different deep reinforcement learning algorithms such as DQN, PPO, and ACN that enable the robot to learn complex behavior through trial and error. So we can integrate deep learning with the traditional motion planning algorithms like A star, RRT that help the robot to plan actions more efficiently by predicting feasible paths and action. Fourth, we have human robot interaction. So, first, we have here natural language processing. We can use different deep learning models to understand and generate human language. This is important for tasks involving human robot interaction where robot need to understand commands or engage in dialogues. So, using deep learning, we can train robots to recognize human emotions through facial expressions, voice, and gesture, that improving interaction quality. Next, we have autonomous system. So, here, deep learning allows the robots to navigate autonomously in complex environment. Now we will try to understand this using an example how deep learning is used in robotics. For example, suppose you are building a mobile robot that need to navigate through an environment while avoiding obstacles. So here we are building a mobile robot. This robot will navigate through the environment and it should avoid the obstacles. Now, this robot is equipped with a front facing camera, and this camera can capture images of its surrounding. So, now we will use the deep learning to classify these images as whether the captured image is an obstacle or no obstacle. The approach is then accordingly we will determine the appropriate action for the robot, whether it will turn left, turn right, or go straight. Simple. We are building a mobile robot that will navigate through the environment and it will avoid the obstacles. It has a front facing camera that can capture images of surrounding. Then using deep learning we will classify the images whether the captured image is an obstacle or it is no obstacle. Then accordingly we will move the robot. If it is an obstacle, then whether to turn left or turn right, or if it is not obstacle, then go straight. So first step is data collection. So data we have here images, that is the robot front camera capturing the images. So we will collect a data set of images from the robot's camera. These images should include various scenarios like clear path, obstacle on the left or right. Then we will label the data. So here we will label the images with corresponding classes like it is an obstacle or no obstacle. Done. We have data as the images. Then we will label the images whether it is an obstacle, no obstacle, like that. Now suppose we collected 10,000 images and among 10,000, 5,000 images labeled as obstacle and 5,000 images labeled as no obstacle. Next step is data processing. Now we will process the data. First, we will resize the images. So we will resize all the images to a fixed size, for example, 64 by 64 pixels. That is used to standardize the input to the neural network. After that, we'll perform a normalization. We will normalize the pixel values to a range of 0 to 1 by dividing by 255. Step, we have the model design. When the model is created, we will start the model training. Now suppose after training, this model achieve accuracy 95% on the validation set. It means that meaning it correctly identify obstacle in 95 out of 100 cases. Done. Now next step we have deployment. So we deploy the train model on the robot now. So during navigation, robot capture an image from its camera. Second, image is now pre-processed. It means it is resized and normalized. Third, the image is fed into the CNN model and which output a probability indicating whether an obstacle is present or not. And this last step we have decision making. Now based on the model's output, the robot will make the final decision. Now suppose if the output is above zero point 0.5, it indicate an obstacle. Now robot will take an action like turning left or right. Second case, if the output is below zero point 0.5, it means robot continues moving straight forward. Done. So here suppose the robot capture an image during navigation and the model output of probability 0.85. This indicate that there is a high possibility of the obstacle is present and the robot then decide to turn right to avoid the obstacle. By using deep learning, robot can autonomously detect and avoid obstacle in real time, navigating complex environments without human. And the accuracy we have here 95%. So in this video we discuss about deep learning in robotics, the role of deep learning and optimization in robotics, how we can build smarter and faster robots. So that's all about this video. If you have any questions, you can comment below and thanks for watching this video.